This computer is fine. Every part works. Nothing's broken, no bug in the code. And it still gave the wrong answer. Something passed through it. You couldn't see it, and the machine just quietly changed its mind. And here's what's strange. Down here, we almost never see this happen, but that's not luck. We live under two shields we didn't build. The air overhead soaks up most of it. Earth's magnetic field bends the rest away. Step outside, and your electronics are on their own. So, what's reaching them? A constant rain of high-energy particles. Some are trapped around Earth. Some come off the sun, but the nastiest ones come from outside the solar system entirely. And here's the weird part. When the sun goes quiet, you get more of them, not fewer. Now, one of these particles is unbelievably tiny. So how could it possibly matter to a computer? Follow one in, past the spacecraft, into the chip, down into the silicon. As it punches through, it knocks electrons loose and leaves a thin trail of charge behind it, and that charge starts to move. And this is where it gets strange. Inside a memory chip, a single bit is just a tiny pool of charge. Barely anything. We've shrunk these chips so much that the charge holding one bit is about the same as the charge one particle drops off. So that charge floods in. The circuit reads it as real, and the bit flips. A 1 becomes a 0. Engineers call that a single event upset. Now, think about that for a second. Nothing actually broke. The transistors are fine. The wiring's fine. The only thing wrong is the number it's holding. Right over it, and the cell works perfectly again. The hardware was never touched. But not every hit is that forgiving. Sometimes a particle trips a hidden path inside the chip, and the current just runs away. That can physically burn the part out. Same cause, very different ending. One is a temporary glitch in the data. The other kills the hardware for good. And this isn't just theory. Back in 2013, NASA's Curiosity rover scrambled its own memory and froze up. The likely culprit? A single particle. What saved it was the backup, a second computer the rover carries for exactly this. They switched over, and it woke back up. So, how do you build a machine that expects to be wrong? You give it memory that catches its own flipped bits and fixes them. You run the same math 3 times and just go with the majority. And you add a watchdog that reboots the whole thing if it ever locks up. So why not just wrap the whole thing in a thick shield? Well, shielding is heavy, and every kilogram costs a fortune to launch. And against the strongest particles, thick metal barely helps anyway. Worse, when one slams into that metal, it can shatter into a spray of new particles. Sometimes the armor makes things worse. Which is why the computers on our most important spacecraft are on purpose years behind the phone in your pocket. Slower, simpler, but built to survive. And even then, radiation-hardened doesn't mean radiation-proof. It just means it's been tested up to a limit. So that perfectly healthy computer that gave the wrong answer, it wasn't cursed by some hostile universe. It was just physics. A real particle, real charge, real silicon, doing exactly what they're supposed to. And every computer, even the one you're on right now, is a physical thing, holding information the physical world can still reach out and touch.